All right, guys. Oh shoot, I don't have this ready. So today we're gonna start chapter 5. We're still doing trig. There's this is a small packet. You will notice there's only 10 worksheets. Okay. The big priorities are simplifying and verifying identities, the trig proof stuff. Does that sound familiar to you? Where you trade out a tangent for a sine over cosine, and we're going to use those Pythagorean identities, sine squared plus cosine squared equals 1. Okay, that's what we're doing today. It's starting in this chapter. And the other thing that's huge in this chapter is solving trig equations. Okay, that's a big thing that has to come out of pre-calc, is that you can solve a trig equation. So 5.1 is identities. 5.2 is actually verifying identities, the proof ones where you know where you're trying to get to. 5.3 is solving equations, and we're going to break that into 2 standards when we get there, okay? Like basic and more complicated, like we did for graphing. All right. An equation is an identity when the left side is equal to the right side for all values of the variable. Okay, so this is an identity. X squared minus 9 over x minus 3 is equal to x plus 3. It's true of all values except x equals 3. Some of you in a minute are going to try to tell me that this is an identity. This is an identity. Where's my cursor? Turn off the sound. We're going to talk about this in just a second, but you kind of remember this one? Comes from the unit circle too, right? The x squared plus the y squared equals the hypotenuse squared. So sine squared plus cosine squared equals 1. Okay, if I rearrange this, I get sine squared equals 1 minus cosine squared. Okay, do you see where someone might have the mistaken impression that sine equals 1 minus cosine? Okay, we spent a lot of time in the last section talking about how things like this don't simplify, right? So you can't square root this and get this. If you were to graph this, think about that graph. The sine of x, whoops, let me do a little bigger here. The sine of x, okay? What is this doing to cosine? This right here. It's upside down, and what's the 1 doing, even though it's in the front? It's a vertical shift up, right? So it's a vertical shift up and an upside down cosine. Are those the same graph as a sine? No. Okay. So just trying to reinforce for you that you can graph things to prove identities, but I'm going to make you do some trig trades as well. All right. These are called identities because we know these are true. The sine is equal to 1 over cosecant. Okay. Cosecant is 1 over sine. They're reciprocals of each other, yes? Okay, and tangent equals sine over cosine. All of these you're good with already, I hope. Which ones are reciprocals, okay? Before we get into this again, the sine of theta times the sine of theta can be written the sine squared of theta. That's how we write it. But if you were to type it in your calculator, this is weird. It used to require that you did this, okay? Now the new operating system on most calculators will let you just do this, which is kind of hurts my little brain because this looks like you're only squaring the theta. Does everyone understand it's the whole function? Okay. Just so we're clear on that. Okay. So we get to the Pythagorean identities. We just talked about this one, sine squared plus cosine squared equals 1. They are on the pink sheet. I'm not going to make you memorize them, okay? This one you should have memorized, honestly. But the other two I know if you go to University of Illinois at Chicago, they make you take a math placement test and you get no reference sheet and it has trig identities. Okay, so just in case, I just want to talk you through where the other two come from. Okay, I don't have the other two memorized very well. At the end of each time I teach it, I might, but I don't have them stuck in my brain. What I do is I take the original 1, sine squared plus cosine squared equals 1, and I divide everything by sine squared. Okay, that tells me sine squared over sine squared is 1. What's cosine squared over sine squared, guys? Cosine squared over sine squared is cotangent squared. And 1 over sine squared? Cosecant squared. Okay? So dividing them all by sine squared, I got this one. It's a different order, but are you good? If I go back to the original again and I divide them all by cosine squared, what am I going to get? Yeah, sine squared over cosine squared is tangent squared. Cosine over cosine is 1, and 1 over cosine squared is secant squared theta. Okay, now do you see where those other two come from? Now, in theory, I could say anytime you want to use one of those, you have to prove them from this one, but I'm not going to do that. All right. Now, the other thing that you need, oh, I had a nice slide for that. Oh, well, I did on the bottom of the last one. The other thing you need to know is that these can be rearranged, okay? Look down here, sine squared plus cosine squared equals 1 means sine squared equals 1 minus cosine squared, or cosine squared equals 1 minus sine squared, right? If you look, and those are not all on there, you need to be able to rearrange them in your head or on paper. But if you look on worksheet 30B, there's a whole big list of them, including like how if you rearrange this, look right here, guys, this one. Cosine squared equals 1 minus sine squared. That also means cosine squared equals, could you factor 1 minus sine squared? 1 minus sine times 1 plus sine. Okay. All right, what about a negative one? What if it said negative sine squared of theta? What could you trade that out for? How could I rearrange this so it said negative sine squared? Well, I could change all the signs, right? And then if I wanted to get that by itself, I could move that over there and I'd have this, or even cosine squared minus 1 would be equal to a negative sine squared, okay? So I'm just trying to show you that those three basic ones can be written a bazillion different ways, yes? At least a bazillion. All right. There's some questions on your homework. I think I only assigned maybe one that deal with this, okay? This is not anything new. This is just draw the triangle. What they wanted you to do is, if this is true, can you find the tangent using an identity? I don't ever use the identities to do these. I just draw them. This tells me to draw it in quadrant 1, right? The sine is opposite over hypotenuse. I do Pythagorean theorem and I get a 4. It wants the tangent opposite over adjacent. Okay. They say you could do like, you could find 1 minus sine squared would give you the cosine squared, and then you could square root, and then you could do sine over cosine to get the tangent. I don't want to use identities. I just want to draw. Okay. So, oh, these are, These are please don't even draw. Read the question first and see if you think you know the answer. Because I always start by drawing and then I realize, oh, I didn't even need to draw. What's going on number 1 here? So the answer is 5/12. And number 2, if the sine is -1/4 and the cosecant is, oh, that's, yeah, pretend that says cosecant of theta. It's a very squiggly mess, okay? All right, you have this one as well, though, and this one might require that you draw, yes? Okay, if I do this, all students take calculus. Cotangent is negative where? Okay, it's negative the same place tangent is negative. This means they're all positive, right? Tangent is positive. So where's tangent negative? Here or here, yes? Okay, so cotangent is in one of those quadrants. This says the sine is what? Oh my goodness. The people who write this on their paper, right above it, they'll write, okay, this is a less than 0. That means negative, okay? Okay, sine is negative. Now what quadrant am I in? 4. Okay, so I know I'm in quadrant 4 after all that. And it says the cotangent. How do I label my triangle so that the cotangent has a -4 and a 3 on here? Okay, cotangent is x over y, and the y should be negative, or it's adjacent over opposite. We good? So now we get a 5 down here, and then it asked for the cosine, which would be 4/5, and it asked for the cosecant, which would be hypotenuse over opposite, right? Did I do that right? Okay, so you could do some of those on the homework. That really, in my opinion, has nothing to do with identities. I could have already asked you those questions on a quiz because they're from when we started this stuff, okay? Because I don't use identities to solve them. Oh, there's another one of these. All right, just determine the quadrant at least for me. Secant is negative means what else is negative? Cosine, right? Secant and cosine are reciprocals. Cosecant is, that means positive. So that means sine is also positive. All students take calculus. Sine is positive here when cosine is negative. Does that seem okay? All right, what does this tell me? That the cosine is the reciprocal of this. Yes? -1 and 4. How am I doing? Did I lose anybody yet? OMG. This is what I got on the quiz the other day. Well, this is -1, so you add it over here. Please know that that's not the case, okay? -1 squared is 1, so we have to subtract it over here, so we get square root of 15, okay? It should be less than 16, right, guys? Because 16 would be the I mean, it should be less than 4 if you get a decimal, because it should be shorter than the hypotenuse. All right. What are we supposed to find? Cosine, anybody? We already found that, didn't we? That was just the reciprocal. Tangent is opposite over adjacent. Is my sign correct? I always worry about that at the end. Yes? The only thing negative was the... All right, any questions on those? I know they're tricky. I totally get that they're tricky, so be careful. All right, even and odd functions, you don't probably remember this test for symmetry, but if you wanted to test if a function was, which one did this? Anybody remember that when you put the negative on the outside? It means if you go to the right, it's anybody remember? Actually, this is wrong. There is no such thing. Goodness gracious, Hofbauer. When you put a negative in here, if it comes out front like this, okay, anybody remember? When the negative, so this means if I go to the left, which of these is that true for? If I go to the I'm sounding like an idiot here. Okay. This would be if I go negative pi over 2, is it the same as going pi over 2 but upside down? So this is odd. Okay. And an even function, it just went away because going negative pi over 2 is the same as going positive pi over 2 because of the symmetry. Okay? All right. I know I just explained that really badly. Oh, here. Look, I had a picture once again already on my slide. All right. So sine was odd. Okay? But what it means is if there's a negative in front, you can put it inside, or if there's a negative inside, you can bring it out in front. Cosine is an even function. You can put the negative inside or take it away altogether because going to the left versus going to the right gets you nothing different, right? So if I ask you what is the cosine of negative 30 degrees, look on your unit circle. Is it not the same as the cosine of positive 30 degrees? Right? Okay. If you look at the graph here, if I tell you to go negative pi or positive pi, am I going to be at the same y value either way? Okay. But the same is not true of sine. If I tell you to find the sine of negative 60 degrees, it is the opposite of the sine of 60 degrees. Check that out on your unit circle. Right? It has the opposite sign. Does that make sense? Looking over here, if I went over here versus went the same direction this way, I get the same y value, but one is positive and one is negative. All right. Too much time explaining that. Sorry. Co-functions. Look at your unit circle. I'm not going to spend time on this today, really, but does everybody see that the cosine of 30 is the same as the sine of 60? Look on your unit circle. Yes? Okay. It's also true that the cosecant of 30 is equal to the what? What's the co-function? Secant of 60, okay? And the tangent of 30 is equal to the cotangent of 60. This is what it says. It says sine is equal to the complement of the co-function. All right, I'm not going to spend a lot of time on this because we don't really use these until we get into sum and difference formulas. Some of you who just took trig have done sum and differences. So I'm going to skip this question and I'm going to go down to the actual simplifying. Okay, so this I think was on your practice, but we're not going to do it, okay? Because I didn't assign one like that on the homework. Is it on your notes? I don't want you to think I skipped something important because it's not on the homework. All right. When you are simplifying or rewriting trig identities or trig expressions, I find verifying much easier because I know exactly where I'm going and I know when to stop. But today is simplifying, okay? In general, to simplify, you're looking to get down to a single trig function. You don't want it to have more than one trig function in it. So some suggestions, you can start by rewriting things in terms of sine and cosines. Use the identities that are on your pink sheet to trade out for things and simplify. You may need to factor. You may need a common denominator. Okay, what does it mean to use a conjugate? Anybody know? If I didn't want this, I could multiply top and bottom by x plus y because I would get x plus y over x squared minus y squared. And if that was a trig question, this might be some kind of an identity I could do, right? X squared minus y squared might be something good. All right. So sometimes to get rid of a fraction, you want to multiply by a conjugate. That's what that hint was. All right. Let's start. Okay, so we want to get this down hopefully to a single trig function. Ideas? Do you remember these at all? What could we trade cosecant for? 1 over sine. Okay. Cotangent we could trade for. We could do 1 over tangent. I generally, if I'm going to switch things to sines and cosines, I switch everything to sines and cosines. So what's the definition of cotangent in sines and cosines? It is cosine, right, over sine. Now, this one was squared. What does that mean? Yeah, they're both squared. Whether you want to write it like this, whether you want to put the little 2 like they did here, whether you want to write it out twice, okay, doesn't matter. Oh, then it says plus. Oh. We might need a common denominator later or something disgusting. But what can we do right now? Nothing nice, right? We can multiply these two together and we get what? Cosine squared over, which I wrote differently, but it's the same thing. Sine times sine squared would be sine cubed. Okay, in order to be able to combine those, what am I going to need? Common denominator. So I need this to be cubed. Can I just cube the top and bottom? The only time you can cube something is if you could cube both sides of an equation. This isn't an equation at all, right? The only thing I'm allowed to do is to multiply it by 1. Well, what's a form of 1 that would help me here? Sine squared over sine squared? That doesn't change the value, right? Because I just multiplied by an equation, a form of 1. So now I have cosine squared over sine cubed over here. And this becomes what? Sine squared over sine cubed. Okay, now what? Okay, if I add them, I can add the numerator. And I keep the denominator, right? What is that? Why is that a good plan? Because this is our very important identity, right? Sine squared plus cosine squared equals 1. All right, so we're down to 1 over sine cubed. I could probably be okay with that. I could, but what is 1 over sine? Cosecant. So this is really a cosecant cubed. All right. In general, if this is a simplification question, you can do some of the steps in your head. Okay? If it's a proof question, it's another story, right? I have to be able to follow every step. But I also give credit, right? I grade based on whether I can tell if it's a concept error or not. So even on the simplify ones, I try to show some steps so I can tell where you got lost if you get it wrong. All right, that one was kind of tricky. Let's hope this one is a little bit better. What do you want to try here? Switch things to sines and cosines together again? So we have a cosine x. Do you want to distribute now or later? You want to wait? What's in the parenthesis? What's tangent going to be? And 1 over cotangent isn't going to get us very far. But sine over cosine would be good. Plus this would be cosine over sine. Okay. Now, again, on a quiz, if you don't want to show this step, you don't have to necessarily if it's not a proof. But just so I'm not losing anybody, I'm going to rewrite, okay, this gets multiplied by both. So when I do this times this, okay, most of you probably wouldn't have written that step out like that, but what do I get here? Careful. Yeah, these can divide out, right? So I just have a sine x. And over here, what do I get? Cosine squared over sine. Was that a great idea? Maybe, but what do I still have to do? Probably. To be able to add, this one is currently over 1, yes? So I need to multiply by sine x over sine x so that they'll have a common denominator. What will that become? Sine squared over sine plus cosine squared over sine, which most of you wouldn't have bothered to write out because what the top is now sine squared plus cosine squared all over sine, which is 1 over sine, which is, okay. I'm thinking, I hope I would see this step maybe. And then would some of you have gone straight to this maybe? And then maybe straight to this and this? Just enough that I can follow to give you credit so I know if it's a concept error or not. Does that make sense, guys? When it's just a simplify one? Okay. Oh, okay, what do you want to do here? Can I cancel this out because someone's going to do that? Oh, I could just put a 1 there though, right? No. Yes, you guys are catching me. You can't do it at all, right? I do want to tell you, you could do this. This might be a good idea on some problems. I'm not too sure that it is on this problem. Because these are two things over a common denominator, right? You could separate it and put each one over the common denominator. Sometimes that's a good idea. Because like this would cancel. I had 1 over cosecant, which is what? The same as what's the reciprocal of cosecant. But is that going to get me any? That's a hot mess over there, right? So I'm not sure that that's a good plan here. But I do want to mention that you can break things apart when you have a common denominator. Okay, you instead want to work with sines. Okay, tell me what to write. Sine over cosine. Guys, it's fine with me if you lose the x's along the way. I do a lot of times too when I'm doing these. Your final answer should have an x in it, right? But if you just write sine over cosine and forget it, sine of x over cosine of x, I won't march you wrong. Okay, this is sine of x times what? Secant is 1 over cosine of x. And it's all over a lovely 1 over sine x times sine x over cosine x. Okay, so let's just work with the top for a second. What can I do up there? Isn't this just a sine over cosine itself? Okay, so what's a sine over cosine plus another sine over cosine? 2 sine over cosine, yes? Okay, what's happening in the denominator? This cancels. So I have 1 over cosine. Okay, now for a lot of us, that means that we would want to write 2 sine over cosine is being divided by 1 over cosine. Which one flips over? The second one. And then it becomes multiplication. So what happens? And I just get 2 sine x. Do you see where that looks a little better than we started? At least I feel rewarded when I do one like this. Sometimes a simplified question at the end looks no simpler to me, and then I get kind of frustrated, like, why did I have to do that? But this one definitely looks better at the end. Okay. How are we doing? I think a struggle for a lot of you on these is if you don't have those memorized, that secant is 1 over cosine, it's a lot harder, right? All right. What's different about this question right away? I see a bunch of squareds in this problem, and I see a 1 plus. I'm thinking we got to check those Pythagorean identities. Pythagorean identities. Anybody know what I'm talking about? It says 1 plus tangent squared. Is that one or not? It says right on your sheet, 1 plus tangent squared equals secant squared. So you want to trade that out right away? So then I have a cosecant squared on the top, and the denominator has a Pythagorean identity trade for a secant squared. Again, if that was a proof, I would make sure you made clear where you got that from, but this is not a proof, so do the trading and I'll follow you. Now what? You want to do sines and cosines? Okay. So the top is currently what? 1 over sine squared. Can I go ahead and write division this way? Because I think it's clear to some of you. It's divided by what is this bottom, which is 1 over cosine squared. And what happens when we divide? Which one flips? The second one, which becomes cosine squared over sine squared, which is a cotangent squared. Okay, again, makes me kind of happy, right? From the top to the bottom, it did get much simpler looking. All right, what do we have to do on 9? I'm thinking we have to distribute, right? We have to FOIL this all together. Can I change it as I FOIL it? Save a little. This times this is actually a 1 over cosine times a 1 over sine, right? Can I do that? Can I change it to sine and cosine as I FOIL it, or is that going to not follow for some of you? Okay, this times this is just a plus 1 times secant, which I could write as 1 over cosine. We good? Then if I do these, can you change that? It's going to be minus. What is tangent? Sine over cosine times cosecant, which is 1 over sine. And then the last one would be minus 1 times tangent, which is sine over cosine. Okay, I foiled, but I also changed to sines and cosines at the same time, trying to save myself some time and effort. Okay, this is just a hot mess. But what happens? Anything good anywhere? Oh, I can cancel those. And then what happens? This is 1 over cosine minus 1 over cosine right there, right? So that just makes 0. That wasn't what I meant to do. I meant to like circle those and say they just drop out. Okay. Then I meant to erase this plus and write, now we have this, right? Minus sine over cosine from back here. Now what do you want to do? Get a common denominator? So this has to multiply by sine x over sine x. Now what do I have? 1 minus sine squared of x. Can I combine them at the same time, guys, without writing it out twice? Right? This is a sine squared back here, and the common denominator is still down there. Don't lose it. Did I lose you on that step? Okay. What's the trig trade for this? Sine squared plus cosine squared equals 1. So 1 minus sine squared would be left over on this side a cosine squared. Okay. So the top becomes just a cosine squared. The bottom is a cosine sine. So what happens now? Cosine cancels one of those cosines, yes? So I have cosine over sine, which is cos tangent. Just kidding. All right. Is that the only way to get there? Probably not. Okay? Probably not. You could have tried to simplify the parentheses first or something. I don't know. Not much, let me tell you. Yeah, this is one of those skills, guys. I'll try to do 10 and 11 as warm-ups tomorrow. Yeah, 12 is just disgusting. Oh, we didn't get very far, did we? All right, so this is what you need to be working on tonight. I'll try to do some more as warm-ups. What I started to say is I can't give you a lot of good applications of this. If you're not going to calculus, this is not something you're going to need the rest of your life, okay? But if you are taking calculus, you need to know how to do this stuff because you got to be able to make trades to be able to differentiate or integrate things, okay?